Hello, this is a video guide on setting up your Raspberry Pi kit for the Tennessee Tech 2021 GenCyber Camp, and I will also be going over some basic Linux commands that you will be needing for some of the challenges we have set up for you this time. So first things first, when you signed up for the camp, you should have gotten one of these. Um, these are Raspberry Pi starter kits by the Labist. Um, and let's go ahead and open it up. So right off the start, this is the Raspberry Pi, and right under that is the quick start guide. So if you want to just go ahead and set up on your own, this is what you would use. And so remove this, and we have over on this side the power cord, or the power supply. We have an HDMI cable that is HDMI to USB-C, and then we have another HDMI cable to USB-C. Okay, going on. We have the case, and it should have inside of it 2 packets of screws, or you should have 2 packets of screws somewhere in your box. Okay, set those aside. And we have this handy thing. This is a USB SD card reader, micro SD card reader. So you put the SD card in the back and you can use it as like a flash drive or a Type C. So that's pretty handy. And that's for if you need to load on a operating system by itself. Then we have the fan uh, that we will be setting up. We have heat sinks, so our Pi doesn't run too hot. We have a screwdriver, and we have a micro SD card that is preloaded with Raspbian, which is the OS that the Pi uses. So that is all that comes with the Pi kit. So now, want to go ahead and open up your Pi, and it should look something like this. It should look like this. So this is the Pi. So I would go ahead and recommend that you take your heat sinks and go ahead and put them on the various components that need them. So there are 3 heat sinks. So this one, this more brass one, or this more copper colored one with all the cubes, this one goes on the CPU. And you just want to peel off the sticker on the back. If I can get it off. There we go. So you should have a black adhesive piece. And this one goes on the CPU, which is this big silver metal one with all the writing on it. And you just want to make sure it covers a good portion of it. And this will help keep the CPU cool. So the next one is this longer one that's more brass colored and has these individual pieces. So again, just take off the sticker on the back. So once again, you'll have this black adhesive piece on the back, and this chip, or this heatsink goes on this longer black processor right here. And I would also recommend holding them down for a couple seconds with only the bare minimum amount of pressure, just so that they fully stick to. So the last heatsink we have here is the smallest one. And this one goes on this chip right here. So it's closest to the power port. Um, so just gonna stick that right down on that processor and push down just a little bit, just so it make sure that it sticks. Okay, so there is all of our heat sinks on, which should help keep our board nice and cool. And now we want to go ahead and put it into our case. So as you can probably tell, this only goes in one way. I should mention that when putting the board into place, you should not use any force at all. It should just fall right into place. So the easiest way that I've found to put this in is to take these big ports and line them up just slightly under this tab for the lid and kind of lean it down. And it should kind of, uh, there's this tab here, right here, that should line up with the edge of the board. And if you notice, it's not fully lined up. And so you kind of go on the other side of this board and slide it in. And you should have a bunch of little tabs like right here and right there that should line up and keep the board in place. So now we want to actually screw the board into place, and that is with the screws, obviously. And so we come with two types of screws. We have a silver and a black, and the silver are for securing the fan to the top of the lid, and so the black are for the Raspberry Pi board, and it comes nicely labeled right on the back. So take these out, and you should have one extra, just in case you lose one. So we take one screw and go into one of the circles on the four corners of the board. So now that we have screwed our board into place, it's time to screw in the fan to the lid. And so if we look at our lid, we can see that there's two spots. This spot down here is for a camera or a motion detector or something of that sort that does not come with this kit. And this top meshed part is where we will be putting our fan. So make sure that we line it up correctly. So the fan should be towards the opposite end of the ports. So the big ports should be opposite side of the fan, and we need them to connect over on this side of the pins, over on this side of the pins. So with that in mind, we want the label, we want the label facing us when we put it in. So it should be something like this. And line up the holes and put a little force, and you should hear snap, and it should fall into place. Now we want to screw them in. So again, these are the silver screws, and the bag is also kindly labeled for fan. So now that we have the fan screwed into the lid, we need to connect the wires to these pins right here, this long strip of pins. So starting on the far side of the board away from the ports, and on the one closest to this line of ports over here, um, we go from left to right and from bottom to top. 1, 2, 3, 4, 5, 6. And that's all we need. Um, and so the red, the red wire is our power line, and our black wire is our ground. So our red line will be going into the first column of pins on the bottom, and our black line will be going into the third column of pins on the top. So if you look at your quick start guide, it's pins 1 and 6. And then we can go ahead, make sure the wire's not in the way, and snap the lid into place. So there is the physical setup of the Pi that we will be using. And if you want, you can go ahead and open up your micro SD and flip it over, and there should be a tiny slot here. We want the golden pins facing toward the board, and just slide that in. Something like that. And so now we are ready to hook it up to a monitor and power it up. Okay, so I have plugged the power cord into a socket, and this power cord goes into the Type-C port, which is all the way on the left. Plug that in, and I've also set up an HDMI into my monitor right here, and this USB-C port needs to go into the first micro port that you see. So this one closest to the power, it needs to go in this one, this first one. Because if you plug it into the second one, when you go to boot it up on your monitor, all you will see is a rainbow on your screen. And that has to do with somehow how the board's made. It'll show that. And I've also plugged up my keyboard and mouse that I have sitting here on the desk. And so now we are ready to go ahead and power it up, and by flipping the switch. And you should see somewhere in there a red light, and your monitor should turn on. So once you power on your Pi, it should go ahead and boot up to something like this. And so if we go ahead and go next, we can set our country, which is United States, American English, and here in Cookeville we are Chicago time zone. And use English language and keyboard. Next. So this is setting password for um, the default user Pi. So we are actually logged into the user Pi. Um, and this is just setting up uh, your screen size, which doesn't really matter to me. So I'm just going to hit next. I'm going to skip that. But you should go ahead and connect it to a network and um, run the updates. And once your updates are downloaded and installed, you should be prompted for a restart, and just go ahead and restart. So now your Pi is completely set up to participate in our challenges that we have planned for you. And now I will go ahead and go through some basic Linux commands once I change my setup around to better record it. Now that I'm all set up for recording, I'm going to go through a couple of Linux commands that we will be using throughout the camp for various challenges. Now this is actually a virtual machine that I'm running, the Raspbian OS, but yours should run exactly the same way. So now Raspbian is a Linux-based OS, and so that means that it wasn't originally built to be a GUI interface, even though we have this nice, pleasing, and easy to use GUI. Its most powerful tool is the command line. And almost all of your challenges throughout the week of the camp will actually be on a Linux system, and you'll have to use the command line to complete the challenge. So to open up the command line, if you're in a GUI system like this, um, you want to go over to this icon that looks like a greater than symbol and followed by an underscore. On some other systems, it might look like a old TV or a monitor. Um, and when you click on it, you should get something like this. Um, so first things first, we have this green text. And this is just telling you um, what user and what system we're on. So we're user pi, which is our default user on the Raspberry system, which is our local system. And then this blue text. So this $sign is just a separation between um, the path and your command line. And this tilde means that we are in the home directory. So our file system is made up of directories, which are, you can think of like folders. So this tilde means that we are in the home directory for the user pi, um, or for our current user, which is pi. And so one of the key skills for a command line instance is traversing the directories. How do we get from folder to folder to view its contents, make changes, whatever we need to do? Um, and one of the key commands is ls, which is which stands for list. So if we type in ls, um, we can see that we have all of these. Now, blue text is a directory, so another folder inside of a folder, and a white text is a normal text file or a some sort of text file, and a green text is an executable file, a .exe, a .sh, um, stuff like that. So another key command is cd, which means change directory. So to get from one folder to another, we use cd or change directories, and we can actually go to, let's say, documents. And if we hit tab, we can actually fill in the rest and we don't have to type everything. So once we hit documents, you can see the stuff before the $sign has changed. Now we can see we are in our home directory and in the documents folder inside of that directory. So if we go ls again, see what's in this folder, we can see that there's a file called text.txt, txt. Um, Now I've created this just for demonstration purposes, so you won't actually find anything in your documents folder. Um, but to actually view the text inside of our text file is one, we can open up an editor. And there are a vast number. And the one that comes pre-installed is VI. So if you type vi text.txt, you can actually open up the file. You can actually change it. But this is a command line text editor, and so it's a little more difficult to use unless you're used to it. Um, so a more simple way to view the contents of a file is with a command called cat. Um, and so if we type in text.txt, so inside of this file we can see that this says this is a sample file. And that is what is contained inside of text.txt. So one thing about every single command that is run or that can be run inside of a command window is that it has what are known as flags or options that can be run with it, so we can actually customize commands and do specific things with them. Um, And so one simple way to actually see this is the ls command. If, as you can see, if we just type in ls, we get text.txt. But say we wanted to view permissions on this file. Uh, we could do ls-l for long. And we can actually see that for this file, we have these permissions. So for these these are the permissions, and they're split up into groups of 3. This dash designates that it's an actual file and not a directory. This first 3 characters are for the owner. These next 3 are for the group, and the next 3 are for the world. So the owner, which is us, we can read and write, but we can't execute because it's not an executable file. For the group, the people who share a group with us can read this file, and anyone else on the system can read the file as well. But up here, you can see that it has a total of 4. But hold on, we can't see these other 3 things that are in this directory. And so if we go ls-a for all, we can see, hold up, there's 3 things that we couldn't see before. We have our text file, but there's this secret folder, and then there's these 2 directories right here, which just basically point you to other places in the file system. Like dot dot is to go back. So if we did cd space dot dot, we can see we are back in our home directory. So let me just go back into documents, ls-a. So as I said, we can see this directory called secret folder. And so if we go into secret folder, we can actually see, and we do ls, that there's another text file in here called passwords.txt. And if we were to see what's in cat, the password file, see what's in it, we can see that it contains the text, this file contains passwords. So another thing that is essential to use in a command line instance are the move commands and the copy commands. Um, so say we are in this secret folder, but we didn't want to actually navigate to this folder every time we wanted to view it. So if we did cp passwords.txt, and then so we want to copy the passwords uh, file, and then we want to designate where we put it. So I want to put it in our home directory on our desktop. So this is the home directory slash desktop. So if we do this, we can see over here that the passwords.txt actually copied over onto our desktop. And so if we ls again, we can see that it's still there. Now if we wanted to rename a file, we could actually do the move command and passwords.txt. And when we designate where we want to put it, just rename it. So secret.txt. And so if we do ls, we can say that the passwords.txt got renamed to secret.txt. And if we cat secret.txt, we can see that it contains the same stuff. Now, another thing I want to mention is that we do not have to stick to our home directory. We can actually explore the entire system. Um, so if we did cd slash, we can see an ls, we can see all of the stuff that we have access to. And this slash directory is our root directory. This is the beginning of everything. This file contains everything in some form or another. Uh, whether it's in this direct file or if it's in another directory in this file, everything can be found within this group of files. Um, this is why it's called the root. Um, so if we were to navigate to home and see what's in that, this was where we could actually see all of the users that were on a system. So on this system, there's only user pi, and so we can actually only go to our own home directory, um, which is here. Now, a lot of things you will need to have elevated privileges for. So if you like kind of running something as an administrator, you might need to run something as root. Um, so say we wanted to get this other text editor called Vim. So we can't just install it ourselves. We have to run it as an elevated user, someone who has privileges. So if we did sudo, which means for super user do, um, apt install vim, we can actually go ahead and install vim. But we couldn't do that if we didn't have sudo privileges or if we were just trying to run it ourselves. So now if we were to go vim test.txt, we can actually uh, write this uh, file. So this is a test, and if we cat test, this is a test. So that is sudo. So one other also super helpful command is the man command. This displays the manual for any given command that you have installed. So if we do man ls, it opens up the manual to run ls. So we can see that we just need ls to run. And here are all the actual options. So we see -a, um, which means we can see everything or all. Um, we can see -d, which just uh, lists directories. Um, and so these are all of the options that you can run with ls, like we did with the -a. So with that, this has been a basic Linux tutorial on what you will most likely need to run in these challenges that we have set up for you. We look forward to having you, and we hope that you have tons of fun and learn a lot with these challenges. Thank you.